Okay, welcome back, and this is probably the last session of this video series, which is related to XEN, KVM, LibVirt, and IPTables. Right, in the previous session I just showed you how you would implement poor man's setup using some configurations in the various configuration files in the system. Such as etc sysconfig IPTables and rc.local, or any other service if you desire so. Now we are going to implement the rich man setup, and the rich man setup states basically, or this scenario is in simple words, that you have the privilege or ability or money, so to speak, to purchase extra IPs, public IPs, which you can assign on the physical interface of your XEN host. Remember, it is different than the ideal setup which we discussed in the beginning or on the top of the document. I can show you again. In the ideal setup, you are a rich person, yes, because you are purchasing extra IPs. However, the service provider is also capable of providing you the ability to use XEN bridge or direct bridging. Since it's not the case, we reverted to using these scenarios, which is either a poor man setup or a rich man setup. And the rich man setup, you are having extra IPs, you have purchased extra IPs, but your virtual machines are still inside a private network. However, this time the redirection is pretty simple, and each public IP can get redirected to a separate virtual machine. This is how we are going to set this up now. It's very easy. First of all, we would need to have two sub interfaces of Ethernet 0 and assign them to different IPs. For this discussion, I've already copied. Oh my god, some crazy people outside. Okay. vi/etc sysconfig network scripts ifconfig ethernet 0. This is our config file for the main physical interface, which is .1.201. Okay. I also have two script files, separate configuration files for sub interfaces, which is Ethernet 0 sub interface 0, as you can see here. This will get an IP of 1.211. It's not 122, remember. It's the same IP of the public network, but 211 is a separate IP. Alright, quit that. And sub interface 1 on Ethernet 0 as well. This one has .1.212 as the IP address. Alright, fine. So these are the two interfaces, and if I do ifconfig and pipes through less, I can show it to you that this is the physical interface IP which we have been using so far, and this is the IP of subinterface 1. This is the IP of subinterface 2. This IP will get redirected to the virtual IP or private IP of the virtual machine 1, which is 192.168.122.41, and this IP will get redirected to the virtual machine number 2, which has the IP of 192.168.122.42. As you can imagine, I believe that it's only the Nat rules which you need to change. You don't have to change any rule in rc.local. The rule we have placed in rc.local is very simple forward rule, which should always be there. And just to make sure that no one deletes this rule, including yourself, you document this, and it's always good to document everything you do. You type something like, do not remove let's put caps lock on the forward rule below, else the outside world will not be able to reach the VMs on this host. This is like, you can put as many warning and like notice, anything you want to write. Okay, just for the sake of fun of it. What happened? Type Q write quit. Okay, yeah, it's there. Alright, sorry for the joke. Where were we? Oops, we forgot to start our timer. Alright, so right, we were discussing that we need to only configure two DNAT rules, very easy, and we would configure our etc sysconfig. My C key on my keyboard is pretty bad, needs some cleaning. Sysconfig IPTables. Alright, so what we are going to do is, if the traffic is coming on pre-routing chain through Ethernet 0, means incoming interface is Ethernet 0, and minus destination is 192.168.1.211, irrespective of the protocol, irrespective of the port, then DNAT it to another destination, which is 122.41. Great. Repeat the same with the second rule. If incoming interface is Ethernet 0, minus destination the packet is looking for is 192.168.1.212, irrespective of protocol, irrespective of port, just DNAT it to destination 42 without specifying the port number. So this will essentially forward any TCP, ICMP and UDP traffic from arriving for this IP 1.211 will be sent all the way to 122.41. Means this is now IP mapping on one-to-one basis. Now how this will work? We have not changed anything in the libvirtual service. We have just changed our two DNAT rules, and for the sake of completeness I'll just show you that my two virtual machines are ready to serve, but my rules are not configured, and I would like to emulate a full reboot for you so that you are sure of that this setup works if a system is rebooted and still works. Okay, here it goes. I'll just put a quick reboot, and I will wait for it to quickly come back. So it will take 2 minutes, right? So we do what? Remember, again, in the rich man setup you are not concerned with ports anymore. It's no more port forwarding, it's IP to IP forwarding. That means port 80 traffic can come for .16, it can also come for .41, and it can also come for .42. That means that you can have a web service or any other service running on Xen host, which I do not recommend anyway, and you can have any service running on VM1, VM2. They can be same set of services, different set of services, nobody cares, because it's one IP to one IP mapping. Right. And I would also, meanwhile my system boots, I want to show you some input rules which you should use on your Xen host. It's under the title of simplest IPTables rule set for your Xen KVM host. basically what I'm doing here is I'm adding these type of rules to protect certain abuse on ICMP. I'm protecting my physical host against any ICMP abuses, such as if someone sends me a packet larger than 85 bytes of size, it will get dropped. And if someone sends me an echo request more than the defined limit, that is 1 packet per second, it will get dropped here. It will get dropped here. This is the limit defined here, that only this would be accepted. And similarly, any echo reply would also be limited by 1 per second, and rest any other ICMP traffic, ICMP type any, would be dropped. So if somebody is sending me ping requests with the rate of 1000 ping requests per second, it will never satisfy this rule, it will never satisfy this rule, it will get dropped here. So these are the rules which you may want to consider using in your etc sysconfig IPTables file. Alright, let's come back to our XEN host, which is booted up now. Right, let's see the rules first before seeing the actual action. Okay, our two DNAT rules are here as expected. See, 211 goes to 41, 212 goes to 42. I highly recommend us a kind of matching between the last octet, which is easier. Ideally I should have had .41 here, which should match .41 here, or if I have .211 here, because I don't have, in the real world I don't have any control on the public IP I have here. So I can definitely use at least the last octet of my virtual machine as 211. So it would always kind of logically match and make sense in the head when you are doing mental calculations. Alright, so this is my rule set in the NAT table. If I just check the filter table, here is my beloved rule, which will ensure that any traffic from left side would reach the virtual machines on the right side. And you see, since we changed the XEN script file and changed -i to -a, the physdev match rules are now appearing at the bottom below the reject rules, and we don't care for them anyway, because these rules on the top are doing everything which we want them to do. So they are already in place. And any input rules which I was just discussing in ICMP rules, etc., you can place them here, right? But no need. My main concern was to show you that my rules exist, and if I just show you with -v, you can see this particular rule which we inserted in rc.local, that any traffic going out on the virtual bridge 0 interface should be accepted. Great. Alright, time for what? Time for acid test. We have not touched anything else, just reconfigure two DNAT rules, and now we should be able to reach every machine. If we do 201 now, we should be able to reach XEN host's web page like this one. This is correct, because this time 201 IP is not being forwarded. Instead, 211, which is the IP of subinterface 0, is being forwarded to VM1 like this. This is VM1 inside XEN host, and this message needs to be corrected because it still uses the old syntax 201:8080, which does not exist. So we will go to 212, and we should reach webmail on VM2 inside XEN host. Lovely. So let's fix this previous one. I want to show you that if you click here, this is basically coming from the cache because it does not exist. Does it? It does not exist ideally. Alright, so let's fix this web page very quickly. Where is that? Virtual manager, and I have to sleep as well because I have to reach my office at VM1 root red hat, and to reach office at 7 I have to get up at 6:30. What a silly time routine. vi various www.html index.html click 212, and no need to specify any port to log on to the company webmail interface. We can add an additional on VM2. Okay, save and exit, minimize, and this thing is why it goes up always. Minimize. This is our famous web page 211. Oh, 211, 201 is like our Zen host now. 211. Here you go. This is private VM1 inside ZenHost. Just click here, and you see at the bottom the link has changed to 192.168.1.212. If I click here, I reach the correct VM, and it's not coming from the cache. If I do refresh, it's the same. That means it's working perfectly and properly. So this was it. And if you insist, then I can add certain input rules to protect your server against ICMP abuse, and that's only if you insist. Of course, I hear you. So I can just copy this and paste here, and I don't have to use IPTables anymore. Be careful when copying and pasting from web pages. There may be variables used inside. Is there any here? No variable in this line, no variable in this line, no variable in this line. Now this, okay, remove the empty lines. I guess that may create problem. Okay. Okay. Now here's the test. There's no mentioning of the interface in my ICMP rules. So if I log on to my VM here and I do a ping to 192.168.122.1, which is virtual bridge 0, but anyway it's an interface, and we did not specify any specific interface in the ICMP rules, so it works, right? If I do a ping flood minus capital F, that can only be done by root. I can flood, yes, but what is the syntax? I think minus F. Yes, it's working. That's why the dot is not going ahead, right? Right, so this is one thing. I will show you how it fails. Let me show you now. Let's first let me send a larger packet size. Ping minus S and like 999 bytes, maybe 2 more 9s. This is a packet size I'm sending to 122.1. It's too large. Oh, okay. Let's have a smaller packet size. 65507. Okay, it's pinging, and it's giving one hell of a time to the server, kind of. Although it's Linux, but still, this is bad, right? This should not happen. Okay, let's go to our Zen host, and let's implement this on the command line because I don't want to reboot the server. Let's implement this one by one. IPTables, and I can copy the rest of the line from here, and then again IPTables, and again rest of the line from here, and again IPTables, and rest of the line here, and IPTables, and this. Great. If I do IPTables minus list minus V, this is a long list, so I would just check input chain. Okay, here is my input chain. If minus v confusing you, okay, here is my chain, and these are the rules which I just added. One drop rule and rest two accept rules, and then again one drop rule. Now let's see what happens. I go to my VM and I do flood again. Okay, now this should generate multiple dots. Previously it generated only one dot. See here. Now this command should generate multiple dots. I'll show you why. See, they're all failing. That's why. Control C, 96% packet loss. Minimize. You see the counters here, they were 0. Let's do minus v this time. You see, so many of packets were dropped in this ICMP traffic here. And okay, next is, though that was flood traffic, right? I send a flood. So the flood is like only few packets got matched to the rate limit, 1 per second, and rest got dropped here in the drop all rule. And now I'm going to send a large packet size. They should get dropped here, matched here, and dropped here. Okay, let's send big packet sizes, and nothing is happening. Previously you saw this output. Now nothing is happening. If I switch my window and I do minus v, I see packets being dropped in the length check. And drop is better, you know, because, okay, let me close this, Control C, 100% packet loss. Drop is better because if somebody is sending you huge size packets, why would you care sending a response back that please, you're sending large packets, don't send me large packets, please? They would not honor this. That is why for such insane traffic, you should simply drop it without even bothering to inform the sending party, because they have this objective of disrupting your service one way or the other. Either they send you a lot of traffic and expect a lot of replies back to them. So that's again engaging your server and its CPU and memory and whatsoever in replying those packets, especially the flood packets. And what if the flood is used? This is interesting. What if size is also used and minus flood is also used, right? This means you are going to F your server, or somebody is trying to do the same which starts with the letter F. Anyway, thanks to these rules here, all of them got dropped. See, 52 megabytes of ICMP packets, they got dropped. Isn't that lovely? That is. Alright, if you reboot now, of course these rules will always be there in your sysconfig IPTables file, and definitely they would do their role to protecting your server. Now remember, this is only an example. This is by no way a definitive list of countermeasures to protect your server. Not at all. This is just an example. Now you can go ahead and place any rules which you want in the input chain in the sysconfig IPTables file, and be rest assured that they would get implemented at the next system reboot or the next service restart of service IPTables. Alright, that's it. Thank you for watching these CBTs. I hope they were helpful and you were able to learn at least some new thing from these CBTs. And now I am sure that you won't be scared to death like many others, and even like myself when I originally started working with XEN and KVM and I encountered this problem. You wouldn't be scared that, you know, what if you mess up certain IPTables rules in the XEN host or KVM host? What if you do this? What if you do that? Now I'm sure that you are perfectly clear that interestingly, none of these rules are required in the first place. I mean the rules which are being used or being introduced by the libvirtual service. They are not required in the first place. If the default policy is set to accept of all chains, everything will work. You only need to do some pre-routing to make sure the traffic reaches from one side to the other to your desired machine and port, and when the traffic goes out from private network to public network, you have some masquerade rules. This is standard procedure. You would follow this anyway in any network, right? So rest of the rules are not important anyway, but now you know that which rules do what, and you are not afraid of them anymore. And that was the objective of this CBT. Thank you for watching, and I hope to bring you more quality CBTs on interesting topics in future. Thank you again. Thank you for your time. Assalamu alaikum.